One important component of graphics is not necessarily drawing something on the screen, but processing an image like the Mona Lisa to either change it in some way or to extract some information from it. So that's what we'll do now. I'm going to create a new Java class called Mona Lisa, and I'm not going to use standard draw. Instead, I'm going to use a standard lib library called picture. Control space, it's important. And I'm going to declare a variable with type picture and initialize it by saying new picture. And the method I want is string, which will be the argument, the file name. So images/Mona Lisa.png. Right, what can I do with a picture? Well, there are a couple of methods we'll look at. One is get xy, which picks up the color at a specific pixel. One is to get the height of the picture, and there's another one for the width down here. And then there's also a set, which will change the pixel color at a particular coordinate. But let's start with the width and the height. I'm going to store the width in W, and I'll store the height in H. And once I've done that, I can write a for loop that goes from 0 up to the height, and another one that goes across from 0 to the width. Oops, I want that to be y. So inside these for loops, I'm looking at each of the pixels in the picture, and I'm going to say color, control space, import that one, and color C will be pic.get xy. So that'll get me the pixel color at coordinates xy. And we've looked before at how to extract components from that color. I can get the red, I can get the green, and I can get the blue. And now I'm going to change them around according to some scheme. You can pick any scheme you want, but for now I'm going to start by setting my new red component to the green, new green to the red, the blue, and new blue to the red. And then I'm going to put back the pixel color. XY will be a new color on RGBB. Fine, good. So I've changed the picture in some way, and finally I'm going to use the method pic.show, which will create a new window, much like standard draw, and show me the picture. So let's save and run. Aha, okay. So Mona Lisa is not looking too well. This is fine, but I can really use any kind of formulation I want here. So let's try something else. Let's try keeping the red component to the red, but subtracting it from 255, which will essentially invert the image. So the new R is 255 minus the old R, and same for green and same for blue. Let's see what that does. Right, so now I've created a photographic inverse of the Mona Lisa image. And next time we'll look at how to do the same thing with HSB values instead of RGB.